Welcome to this module, which will provide us with an overview of the ELK stack. We hope you are excited to learn about this amazing data exploration tool stack, the ELK. Over the years, the ELK stack has become quite popular. In this module, we will understand the problems that ELK seeks to address and the distinct benefits it offers. Once we witness the power and the features provided by this robust framework, it will be evident why ELK stands out apart and above other data exploration solutions. The Mars Curiosity rover has been exploring the red planet and collecting billions of data points about the different aspects of the planet using its sensors and probes. A crucially important problem for NASA was how to analyze telemetry data from the Curiosity rover 150 million miles away. For example, if NASA could correctly predict the thermal parameters, Curiosity's drive time on Mars could increase dramatically, which could lead to new and groundbreaking discoveries. Conversely, a mistake could seriously affect the $2 billion mission. Originally, NASA operation personnel painstakingly collected the thermal telemetry data that experts later analyzed. This took weeks and did not allow for interactive analysis or data collation or comparison of information collected from several Curiosity instruments. This added cost, risk, and led to lost opportunities. The solution? NASA created an analytics cloud where developers and end users could safely innovate together and experiment with new capabilities using the actual spacecraft data. There, they prototyped a new interactive real-time analytics tool called Streams. As Curiosity's data arrives from Mars into the pre-built, hardened operational system, it is copied into the Agile Analytics Cloud, where analysts can query and interact with the data using real-time visual analytics of over 1 billion telemetry data points, 26 million alerts, and 100,000 images, which is growing daily. They can also easily collaborate with experts located anywhere around the world. The data analysis of this massive dataset is done based on Elasticsearch. NASA claims that using the Elastic Stack, they get quick insight over multiple days of data or even the entire mission in just a few seconds without any delays. Let's take another example of modern-day taxi or cab hailing apps like Uber. The key value provided by these apps to the end consumer is that they can look for an available taxi or ride in the vicinity of their current location and book their ride in a matter of seconds. How exactly Elasticsearch helps these types of businesses? What happens is that as a user, you register on the Uber platform and so does the driver. Then, at the time of transaction, Uber tracks the location of the users and all the drivers on their platform. This real-time location data for both the users and the drivers is stored in Elasticsearch. Elasticsearch stores this data in the form of longitude and latitude. When a user requests a cab, Elasticsearch finds the user locations and then it matches the location of the user with the location of any available drivers near user's proximity. So you see, Elasticsearch is a very versatile search engine which is capable of processing unstructured data like logs and also structured data like location-based geospatial coordinates. You must have heard the term big data. In the recent years, this term has been gaining popularity across the industry. There has been a paradigm shift in the volume of information and the ways in which it is extracted from the underlying data. ELK is one such new age method for data exploration. Let's talk more about big data, but before moving ahead, let's first define what big data means. Big data is a blanket term or a catchphrase used to describe any collection of structured or unstructured datasets which are so large and complex that it becomes difficult to process using traditional database management tools or data processing techniques or software architecture. In other words, the dataset volumes are so large that we cannot use tools like spreadsheet tools, relational databases, etc. to process these datasets. In these scenarios, the volume of data is too big or collection of additional data is too fast that processing these datasets exceed the capacity of traditional tools or techniques. Despite these big problems, big data has many benefits. Processing these datasets can help companies and individuals gain better insights about the data or their businesses and improve the operational efficiencies. They say time is money. Using big data processing techniques, you can gain these insights about these large datasets in very short period of time and even almost in real time, which translates to faster and better decisions. With the added capability of big data processing, we can now build new products and services, stretch the boundaries of science, and venture into new research areas which was not possible earlier. One of the biggest reasons of data size growth is that we have billions of additional devices available to the users in shape of smartphones, IoT devices, which are consuming and producing loads of data every second. Internet access and connectivity is becoming ubiquitous in most parts of the world. This makes it very easy for these devices to upload and share this data with others. All this data eventually gets captured for further processing, sharing, and analytics. Let's determine what caused this big swell in the size of datasets in recent years. Let's examine what kind of data growth trends we are experiencing by looking at some numbers from 2012 from popular search media site Facebook. In 2012, Facebook was reported to have 2.5 billion content items posted every day, 2.7 billion likes daily, 300 million photos were uploaded by users every single day. While Twitter has reported 500 million tweets every day, or roughly 200 billion tweets on a yearly basis. Similarly, Google reported 20 petabytes or 20,000 terabyte data processed every day. Let's now move our attention to some traditional datasets. The largest relational database is being used by AT&T, which is about 320 terabytes in size. The AT&T Call Records database has 1.9 trillion unique rows in the database, which is the second largest number of unique rows. It is estimated that 90% of digital data generated by human race has been generated in just past 2 years. 80% of this data is unstructured data like photos. This tremendous growth in data and big data technologies could be characterized with 3 V's. First V is volume. Here, the volume represents the size of data. As we just saw, we are collecting larger and larger datasets ranging in terabytes or petabytes. This is a combination of structured and unstructured data. Next is velocity. This represents the speed at which data is being generated and or is being ingested by our systems. There are applications which are collecting very high velocity data like click streams, signals from IoT devices, server logs, etc. These data streams are being generated at gigabytes per second and are being ingested for further processing. Last V is variety. Variety refers to the different kinds of data that our systems collect. It could be structured data or unstructured data. Structured data follows some recognizable patterns, like comma delimited format or relational data. This structured data is well understood by machines, whereas unstructured data refers to things like photographs, binary files, and so on. For the most part, structured data refers to the information with a high degree of organization. As such, inclusion of this structured data in an organized system like relational database is seamless. This type of data is readily searchable by simple, straightforward search engine algorithms or other search operations, whereas unstructured data is essentially the opposite. So how do we deal with the problem of processing such large amounts of data and finding key relevant insights within seconds? Several tools have sprung up to address this problem. The first one you may have already heard of is Hadoop. Hadoop is an open source Java-based programming framework that supports the processing and storage of extremely large datasets in a distributed computing environment. Several NoSQL databases have been gaining popularity lately. Databases like MongoDB, CouchDB, and Cassandra can scale horizontally and make use of clustered compute and storage capacities of hundreds or thousands of machines joined together. All this data flowing across the network needs several data processing jobs. ETL tools like Talent are designed to help with data integration, data quality, and data management. And what is the end goal of processing all this data? It is to gain actionable insights which can help make important decisions in several fields like medicine, science, business, and so on. Business analytics tools like Jaspersoft help us accomplish these goals. Yet another set of tools which are instrumental in processing large amount of data is ELK, of course. ELK is a bundle of technologies which consists of a very powerful analytics platform. And the incredible thing is that it is all free and open source. Let's explore ELK better. The ELK stack contains the following three components: Elasticsearch, a powerful open source search and analytics engine that makes data easy to explore. It is a search server based on Apache Lucene. Logstash is a log management tool used for centralized logging, log enrichment, and parsing. Kibana is a browser-based HTML5 dashboard used to visualize Elasticsearch data. The open source ELK stack provides the ability to perform operational and data analytics, including deep search functionality, on almost any type of structured or unstructured data source. The ELK stack consists of Elasticsearch, Logstash, and Kibana. Although they have been built to work exceptionally well together, each one is a separate project that is driven by the open source vendor Elastic, which itself began as an enterprise search platform vendor. It has now become a full-service analytics software company, mainly because of the success of ELK stack. Wide adoption of Elasticsearch for analytics has been the main driver of its popularity. Data constantly flows into our systems, but it can quickly grow to be fat and stale. As your data grows larger, your analytics will slow down, resulting in sluggish insights. And this is likely to be a serious business problem. So the big question for your big data is, how can you maintain valuable insights in timely fashion? Not long ago, an epiphany ran through the industry. Analytics is in a sense a search problem that needs coupling with good visualizations. So there was a marriage. Lucene, with all its search goodness, was brought together with the distributed computing goodness that is Elasticsearch. Logstash came into the scene to normalize all kinds of time series data. pop in Kibana's ultra simple visualization tool, and you have a complete analytics tool that can rival very expensive and scalable solutions from Oracle, Palantir, Tableau, Splunk, or Microsoft. You too can play with the big boys for a lot less dollars. The diagram above shows a typical flow of data in the ELK stack. Consider Logstash to be an event processing pipeline which collects data or logs from various sources of your IT infrastructure, enriches it, and stores the event or log streams as a JSON document within Elasticsearch. Elasticsearch is a distributed document repository to store and analyze JSON documents. It provides rich and powerful functionality to query and search data within the documents. Kibana is a rich web-based application which can be easily integrated with Elasticsearch to quickly generate real-time visualizations important for making any business decisions. And here are some core benefits of the ELK stack. Scalability. As the name suggests, the ELK stack offers incredible elasticity with a massively distributed structure that allows you to start small and scale horizontally by adding more nodes to your network as it expands. Reliability. Elasticsearch clusters help to detect failed nodes in order to organize and distribute data automatically so that your data is always accessible and secure. Any changes are recorded in transaction logs on multiple nodes to minimize data loss. Flexibility. Elasticstack offers full text searching capabilities with a query API that supports multilingual search, geolocation, contextual suggestions, autocomplete, and result snippets. Logstash can work with multiple data sources like files, databases, metrics, and so on. It unifies all your data streams, whether it is logging data from web server, sensor or signal data from the IoT devices, or binary files being uploaded by end users. Automation. ELK stores and automatically indexes JSON documents, making them searchable. It also optimizes the storage of the data on disks. ELK provides a rich JSON API which is accessible over a simple RESTful interface via HTTP, which makes it very easy to use. User-friendly, the deep integration with Elasticsearch and Logstash helps to visualize both structured and unstructured data that is indexed into Elasticsearch. Using these tools, we can easily create charts, plots, histograms, maps, and so on. We can visualize the information provided by Elasticsearch and present it in a digestible form. This leads to better insights from the data. Since ELK is so scalable, robust, and flexible, it can be used to process petabytes of data, and it can handle any extremes of the 3 V's of big data paradigm. Last but not least, it is absolutely free. Built on Apache 2 using Apache Lucene, it is all open source, allowing you to download, configure, and modify based on your requirements. In an enterprise, there are tens or hundreds of applications running simultaneously and serving the needs of the business and consumers. The true value of ELK shines when we get all the logs originating from these applications into a single instance of ELK. ELK has the capability to correlate the data coming from these different sources and truly find some amazing insights. In these scenarios, it is awesome to have all of your data aggregated in one place so that you can see the process flow and perform queries against the logs from all applications into one place. So ELK stack eliminates the need to log into hundreds of different log data sources and follow these logs. You can aggregate all the logs and visualize them in one place. If the logs were not aggregated, it would be very hard to find answers to certain type of questions, even if we knew the answer lay in the data available to us. But processing that data and finding the relevant answers will be certainly complex and pose a barrier too high that in most cases we just would not get the right insights to make the right decisions. Welcome to this module on cloud computing and AWS. In this module, we will talk about the AWS ecosystem, its services, and how you can implement AWS cloud services for your own needs. In this module, we will introduce you to the concept of cloud computing. In the context of Amazon Web Services, we will see how AWS is conquering the world of applications through the promise of scalability and sophistication. This is a foundational module. The information in this module will help you to understand the basics of cloud computing and why AWS has proven to be the cloud platform of choice for many companies around the world. In case you are already familiar with AWS and its service offerings, then feel free to skip this module and jump right onto the next module, in which we will talk about the core topic of this course. This is an overview of this module about cloud computing and AWS. Here are the key outcomes you can expect to take away from this module. After completing this module, you will be able to understand what cloud computing is and comprehend various benefits cloud computing provides. Discover why companies are switching over to cloud computing and in particular to AWS Cloud. Identify prime AWS users and learn why they are using it. Realize how AWS can help your business and expand it. Explore AWS services and learn to run your workloads using these services, and apply this knowledge and begin using AWS services for your own needs. Alright, so let's get started. Let's review the basics first and understand the most important and basic term, cloud computing. So what is cloud computing? Cloud computing is a general term used for the delivery of hosted services over the internet. Cloud is a broad and deep platform that helps customers build sophisticated, scalable applications. Cloud computing enables companies to consume a compute resource such as a virtual machine, storage, or an application as a utility, just like electricity. Rather than having to build and maintain computing infrastructure in-house, you can just pay or lease some time on these compute resources and use them for your purposes. Next, let's see why companies are switching over to cloud computing and in particular to AWS. Traditional methods of hosting and administering IT infrastructure meant we had to deploy monolithic data centers and physical servers. The lead time for this heavy infrastructure deployment was few days to few weeks. It needed large amounts of capital spending upfront. This model often led to energy wastage, low utilization, and high efforts for the administration of hardware servers. It was rather difficult to scale these operations very quickly, whether it was to expand the operation to meet growing demand or to shrink operations due to reasons like seasonality. Cloud is a generic term used for a platform that provides hosting services over a network. At the core of cloud computing is hardware virtualization. Because of this, cloud infrastructure can provide us access to shared pool of computing resources which could be rented or leased on on-demand basis. Some of the main benefits and driving forces behind cloud computing are that cloud computing allows companies to avoid upfront infrastructure costs and focus on projects that differentiate their services and products. In the recent years, this has enabled technology startups to invent and come up with innovative technologies and products without worrying about spending a lot on upfront fixed infrastructure. Cloud computing allows enterprises to get their applications up and running faster with improved manageability and less maintenance. Cloud computing enables IT department to rapidly adjust resources to meet fluctuating and unpredictable business demand. Major cloud providers are vastly trying to use renewable energy sources to run their data centers. And they're also coming up with more efficient data center designs to reduce energy consumption per unit of computing resource. This obviously has tremendous advantages for the environment. Since cloud providers can manage their data centers more efficiently and cheaply, these savings can be passed on to the cloud consumers. The availability of high-capacity networks, low-cost computers, and storage devices, as well as the widespread adoption of hardware virtualization, service-oriented architecture, and atomic utility computing have led to a growth in cloud computing. Companies can scale up as computing needs increase and then scale down again as demands decrease. Cloud computing has become a highly demanded service or utility due to the advantages of high computing power, cheap cost of services, high performance, scalability, accessibility, as well as availability. Some cloud vendors are experiencing a growth rate of 50% year over year, which is just astounding. Cloud computing can be deployed in multiple configurations. The most popular configuration is, of course, a public cloud. These cloud services are provided by public cloud provider companies like Amazon, Microsoft, Google, Rackspace, etc. Any individual or company can pay appropriate fee and buy the required services from these public cloud providers. The services are isolated for the individual customers so that there is no interference with other customers' data or compute resources. But the cloud consumers do not have any control over the underlying infrastructure and hardware of the cloud resources. When companies need more control over their infrastructure, they deploy shareable IT infrastructure in their private data centers. This provides the facility and convenience of a cloud company to all the consumers within the company, at the same time giving more control to the company over their resources. But in many situations, companies need to adopt a hybrid approach where they make use of both public and private cloud infrastructure. These two separate segments are joined via a secure network link, and the IT resources in both public and private clouds can talk to each other. This configuration is called a hybrid cloud.